Hi, so I'm Gary Frost, and I believe that financial service companies carry too much risk and it's time to embrace continuous delivery. So I'm the managing director of a software delivery company, and we work a lot with financial services. We do a lot of big data projects, and we try to use continuous delivery where possible to do so. I've about 20 years of investment banking IT experience. I worked in 10 different banks in 4 different countries, and I consider myself a battle-scarred, agile pragmatist. I've done waterfall, done XP, I've done Kanban and Scrum, and I've come to the conclusion that pragmatism is the key for successful project delivery. So, unless you've been living in a cave for the last 8 years, you'll know that the financial services had a lot of undisclosed and unknown risk, which nearly broke the entire world economy. So I'm not here to talk about that type of risk today, but rather about the software delivery risk. That is either accidental or malicious code changes that are introduced in production, the loss of information and various security and hacking attempts, when we release a change that negatively impacts performance or causes system outages, or failed deployments that have other impact. But there's also a big risk in agility, our ability to deliver on time, cost effectively across these organizations. So I'd like to start with a little bit of history, personal history. So nearly 20 years ago when I started in investment banking, I was working for a small Australian investment bank, and we used to work directly with the business. We would literally sometimes be on the trading floor working with them. We could take a feature, we would implement it in development, we would run some unit tests, and then we'd push it straight to deployment, to production. Now, that allowed us to be very, very rapid, but it did introduce quite a lot of risks. We were certainly in a high velocity and high risk model. There's one example that I'd like to start with, which is something I'll never forget, even though it was nearly 20 years ago. I was only a couple of months out of university myself and working on a mortgage, on a bond trading system. In the morning, I'd been logged into production and I was fixing a production issue. And in the afternoon, I was then working on a new feature. I can't remember the exact details of that feature change, but I do remember that it had a database component to it. So in my development environment, I dropped the order table. I then ran in a new version of the table and started injecting some test data. I was working out why my feature wasn't working when the phone started ringing. 1, 2, 3, 4. And I think it was about the 5th phone that was ringing when all of a sudden my stomach dropped. And I looked and I checked, and I had gone and deleted the production database. I stood up and shouted to the team, "Oh my God, what I've done." And they all rallied around. We fixed the problem. We were out in the market for the rest of that day. We worked late into the night to get this problem solved, and we were back in the market the following day. So there was no change control, direct access to production, little in the way of testing. I think of it, fondly like the Wild West. But there were lots of similar failures in the 90s and the noughties. This, I believe, is the largest known software failure in history. I could be wrong. But in 1996, the First National Bank of Chicago introduced a software bug that meant that 823 accounts were each credited with $900 million. That's a $746 billion error. Now, all funds were recovered, and over a couple of weeks, they got all the money back and they fixed all the systems. But even if you run the interest for a day, it's tens of millions of dollars. Likewise, in 2004, there was another issue with a US bank, and millions of customers were affected, and they claimed that their total loss was 100 million on this. We've seen issues where exchanges have gone down. In 2005, a major exchange did a software release, caused the entire market to close for the entire day. And you can imagine, what that was like. So I feel a little bit bad about my, taking out the order table. At least it wasn't a $10 or $100 million bug. And we all learned a valuable lesson. Don't give the newbies access to production. So with so many failures and so many, you can imagine there's been a lot of reviews. There have been lots of audits and reviews and regulations and recommendations. One of the biggest ones is Sarbanes Oxley, or SOX, as it's known. Now, SOX wasn't actually entirely focused in IT. It was more about accountant fraud, embezzlement, and that. But it did have an IT component. So SOX requires, from an IT perspective, that there are comprehensive audit trails, there are IT process controls, and there are operation controls. On review, a lot of companies found that their SOX compliance breaches actually came from IT departments. Now, SOX did mention segregation of duties, but it was more about business units not being able to, having segregation of duties. But it's become common practice within IT to have segregation of duties. Typically, it's recommended now that you'll have a business person who identifies requirements. There's a governance board to authorise that that's an appropriate requirement and to be implemented. The developers then do the designing and coding, often working with a test team, separate test team. Then you'll have a number of bodies to review and inspect it, architecture teams, security teams, data teams, and so on. And then a separate ops team and sysadmin team to implement that in production. And it's said that no person should be in more than one of these roles. So we've got lots of different segregation here. So in a typical investment bank or in most financial services companies now, after a request has been made, and it's actually been approved and funded and coded and tested by a QA team, and it's ready to go into production, there's at least a 2-week process. In most places I know, you've got to raise a change ticket 2 weeks before it can actually be implemented. And in that time, an architecture team will look for standard patterns. Is there any simplification? Are you using authorized and licensed software? Is the open source software approved? There may be a database review looking at data structures, data flow, and so on. Security team is certainly a big issue. They'll review a number of features such as encryption, clear text passwords, and the like. Information classification review happens where they look to see whether it's public, confidential, or highly restricted data, and if so, are appropriate controls in place. The operations team will need to go through your support documentation on how they're going to support this feature and go through what's often a 10-plus page run book of how they're going to deploy it. These run books are normally in Microsoft Word and copied and pasted in when they're doing the deployment. And all of this is managed by a change control team who helps coordinate all these changes with all of these reviews, make sure everything is signed off, and that you then have appropriate sign-off from upstream and downstream systems and when it can be scheduled. And that's just for a normal change. If you're making a major change or a new system change, this can be 6+ weeks. It's recommended get involved a couple of months in advance. So it should be obvious that this is incredibly time-intensive. So you need a lot more staff involved in all these review bodies. Lots of time is spent in meetings. It tends to cause architectural inflexibility, and certainly it causes a lower release frequency. If you're doing this process, you don't want to do this every week, do you? You tend to batch lots of changes up and do it every quarter. And that reduces our agility, our return on investment. But also, when it comes to talent acquisition, it's a competitive market. And if you've got the option to go and work for some startup where you've got direct access and you can use all the greatest tools, or you can work for some bureaucratic company where it's impossible to get anything changed, then you really do struggle to acquire the best talent. But if that's the cost, then surely we know we've moved to a low velocity, but we've moved to low risk, right? Well, interesting, Jez this morning said, and I agree, no, we haven't. We've moved to low velocity, but we're still high risk. There's only a marginal change improvement on our risk profile. So my research, you can look at a number of incidents, and there are dozens and dozens you can look at. But here's some that happened since all of these changes have been implemented. 2012, RBS, NatWest, and you may remember this, was out. 12 million customers were impacted. They were out, payments were disrupted. The bank ended up getting fined 54 million, but there was probably other losses as well, and they've had 3 other incidents since 2012. This is possibly one of the biggest ones that's happened since, and this was Knight Capital. They made a change to some functionality, and they were using a test flag. They deployed this new order system out to 7 of 8 servers. And when orders were routed to that 8th server, what happened is it caused test code to be executed, which impacted the price. So it was putting test prices into a live market, spiking and dropping prices, crazy. In 45 minutes, they lost 440 million and effectively became bankrupt. We can see other examples. 2015, Barclays was down on their mobile payments and card processing. HSBC had a problem with their ATMs and so on and so forth. There are many, many examples. So the question is why? If we've put all of these safety measures into place, then why are we still failing? This is a fairly typical architecture document, right? Now this is actually for a mortgage system, and each component and all of their flows goes into that one single mortgage system. But over years, we've got legacy and we've done mergers and acquisitions, and it's not uncommon to have many, many instances of a system. There's one bank that apparently has 50 mortgage systems, all something like this. But then you've also got your loans and your payments and your internet banking, and if you move into investment banking, then you start getting into your trading and market and so on. Now, I once saw an attempt to draw a bank's entire architecture diagram, and each box was only about this big, and it covered this entire wall. That's a lot of complexity. So we end up with thousands of systems. One bank that I'm working with has 8,000 systems with 35,000 technical staffs working on it. So how can any architecture team truly understand the end-to-end flow and the impact? Likewise for operations, how can they truly understand what a change is going to do? The same with security. So then, if we've got many releases going on per year for each system, we end up with a huge explosion of in the change review process. I've seen the workload of some of these change teams, and it's horrific. They have got thousands and thousands of change requests to get through. So how can they truly apply the time that's needed to do due diligence and really do a detailed analysis of every single change? The truth is they can't. So Jez put it nicely actually earlier, which is it's change and risk theatre, and I think that's what this causes. So how do we solve this? Well, I'm at a continuous delivery conference, and I think continuous delivery is how we solve it. Now, if we start by obviously going and looking at our source code control, you should be using a modern version control system, something like Git, do pull requests. Some people say don't do pull requests, do pair programming, and that's fine. And do code quality checks, use something like Sonar to check whether you've got any known defects or high complexity code and make that a build breaker. And go for trunk-based development and build on every single change. Use a binary artifact promotion system. Now, the truth is a lot of people are already doing this. A lot of the banks are in various teams, and if you're not, then do it and get there very, very quickly. But we've got to look beyond that and go for full automated testing. If we look at what happens in one of these typical change review processes, and then we actually find that a lot of it can be automated. Certainly when we look at security testing, scanning the code for clear text passwords, that's fine. Checking for encryption, that's fine. Can we then also check endpoints and look through port scanning and so on and so forth? Yes, we can. We can automate all of those processes, and we can make it part of our build pipeline. Likewise, are we using authorized software? Is it on the approved list? That can be automated, just hook in. Performance testing is best done by computers, let's be honest, so let's just make sure that that becomes part of our build pipeline. But as we go up the maturity models, we can find more and more opportunities. If we start looking at consumer-driven contracts, so when you define your system, all the consumers of that system write contracts with tests, automated tests, which are the contracts, the expectation of that system, then when that system changes, you can run all of those contracts and ensure that everything's still working fine. And then the deployment. Now, I've seen lots of failures in deployment where people have been running through a 10-page run book, and what they've done is they've copy and pasted, and I saw a horrific one once. They copy and pasted an RM minus RF slash da-da-da-da-da, new line, and it went on. It went on at a slash, and there was a space, and you can imagine the chaos that happened, right? So, we've got to move towards one-click automated deployments. Let's embrace infrastructure as code. Let's make sure that all of our infrastructure has certainty between it. We should be able to click an environment, click a button and provision an environment. But more than that, I think we're in a very exciting time when it comes to things like containerizations. Now, if you start adopting a microservice approach to your architecture and you adopt containerizations, you can start isolating a lot of these problems. create containers with containing microservices. They're easier to test from contracts. You can isolate your security testing and your performance testing and so on, and you can build a dependency graph of how these all work. And then we're now starting to look at orchestration and data center operating systems for the data center, Kubernetes and Mesos. So we can start getting to a point where the ops team and the sysadmin teams, they aren't worried about running through a 10-page runbook and getting deployment steps right, but they're more worried about live performance testing, hotspots, and auto-scaling, and so on and so forth. And this starts getting us towards a living architecture document. If we also add on to this that we can do metadata analysis, and map our data flows, and start to generate architecture documents that are written statically are out of date almost the time they're printed. Whereas if we move to systems where we've got containerization and all of these techniques, we can actually build a living, breathing view of our enterprise. So our enterprise architects can now have a look and start looking for utilization and rationalization opportunities. Our operations team can certainly quickly identify hotspots and tune the parameters and so on. Obviously, the business can help to see where the value of investment is. So we can get to the high maturity build pipelines that does everything. You provision an environment, you run your build tests, you go for full end-to-end testing, security testing, performance testing, and ultimately promotion. But the key, of course, is test all the time and automate all the things. But there are blockers. And in my opinion, one of the biggest blockers is the way we have segregation of duties and the silos. Now, if you've got change review teams which are under extreme pressure to review every single change, and they're incentivized to manage risks, then their default position tends towards, no, it's unsafe, don't ship it. And if you've got development teams that are under extreme pressure to implement features quickly for the business, then their default position tends to be, yes, it's safe, ship it. And we've got conflicting concerns. So the key is not just tooling, but it's also building highly collaborative environments. Moving away from the silos and more integrated teams where we have people that are in the development team worrying about security, information security, automation, operations, deployment, performance, and so on. So that we're all working together to say, how can we write an automated test for that? How can we do destructive testing? How can we simulate a rack going down? Now, we use a lot of open source software in the banking world. We should also look to high-performing industries. I'm not sure if anyone's seen the engineering culture at Spotify videos. If not, spend 20 minutes. They're exceptional, really, really good. Now, imagine these are our development teams, and on each of these development teams, we have security specialists that are working across the teams and across the groups to create more standard tooling and some patterns that can be reused across each team. Look to Google and how they can have 15,000 developers all working on trunk-based development, and every time a change happens, it works out the impact to every system, builds it and tests it and ships it straight to prod. By adopting these types of techniques, I think we can truly move to a high-velocity, low-risk model as opposed to where we are today. But it's not trivial and it's not cheap, because if it was trivial and it was cheap, we would have already done it. And it's not about tooling. Should we use Jenkins or Team City? And it's not about hiring a DevOps engineer to write some build scripts for you. It requires complete change in process, and it requires support all the way through the organization. Now, there are isolated success stories. At 51.0, we've delivered some pretty good big data solutions for a number of banks, and we've used continuous delivery to do it within the limits that we could do within the banking organization. So I say go and find those success stories, study them, and replicate them. Now, there's one other risk I'd like to touch on, which is the financial services, the fintech disruption risk. As it stands today, there are a number of fintech companies that are finding a market. They are innovative, they are well-funded, they do not have this legacy code, and they are moving very, very fast. And I think this is now a threat to the established financial service companies. So, to the established companies, I say, you've got two choices. One, move to a continuous delivery and DevOps model where you're building highly automated processes and building an efficient pipeline, or don't. And so that's all I had. Thank you for your time. And did I have I thought I would have run out of time.
You've got 5 minutes for questions.
There we are. I was pretty sure I would have run out of time. But so any questions?
Yeah, small question. Is
Yeah.
this presentation available to view after this event?
If the slides aren't going up, I'm not sure if they are going up. Yeah, they are, but also I'll put them up on Twitter and LinkedIn and stuff like that.
Just a question about you went through a number of examples of failures that had happened over the previous decade, I suppose.
Yeah.
So do you believe that if large banking organizations adopt a DevOps mindset, a DevOps approach, that those failures would have been mitigated, wouldn't happen?
Would have, or going forward?
Going forward.
Yeah, I mean, there are still going to be failures, inevitably, but I think we're in a position to start. We don't do adequate testing now because we just don't have the right amount of time to do so, and our systems are so complicated. But if we use robots and machines to do sophisticated testing for us, if we invest a lot of energy and effort that currently goes into a very intensive process, we spend a lot of money on change control. If we start putting that money into automated testing and building in quality into the product, I think there will be less incidents, and we'll spot them quickly and we'll fix them quickly.
Just a comment from, again, I think a hardened agilist rather than a starry-eyed one, having spent 10 years in financial services for investment banks and asset managers. I don't disagree with anything you said about the fact that this would be a good thing to do.
Yeah.
My comment would be, I think the investment requires a long-term kind of thinking, which, given that senior MDs in investment banks rotate every 2 years, is quite difficult to bring into many organisations, because the payoff is often at least some way into the future.
Yeah, I do tend to agree. I mean, I think that it does require an investment, but what I'm keen to do, and I think I'm going to do after this, is start getting some figures on how much we spend on our change control process that doesn't work. And then if we start diverting some of that cost into improving our systems and automating everything, then we can get it. To the MDs that don't see the value of the investment, I say, do you want a $764 billion case? Do you want to be in the news? And do you want to be disrupted by the fintech companies? Because they are really coming after you really, really fast.
I don't find that bit of argument at all, but that's another discussion.
Yeah.
One of your pieces of advice was to find successful companies and study them, that have been down this route. And I've been following a blog for Standard Bank. They've been on a journey, and they've got a kind of a mobile top-up application that touches on their mainframes that they can update now. I think it's every 18 minutes. So do you know, in your experience, is that about choice of tooling or change of process? I mean, are there tools that will allow you to kind of work with mainframes in that kind of world, or is it mostly about getting the change review board out of the way?
I mean, I have limited experience, to be honest, in the mainframe world, but I think you can still apply a lot of the same processes, and maybe the testing is different, but it's the same sort of approach, automate the tests. But my experience in most of these organisations, they are largely Java and .NET, and most of their infrastructure is not mainframe these days. And you're right, there are a lot of successes out there. There are a number of banks, ING, Deutsche are doing a massive program of work looking at literal continual deployment. They're really leading the way. And I think over the next few years, some banks will fold because they haven't done it, and some banks will succeed, and they'll thrive. Lovely. Thank you.